Section 5.3 is kind of a quick section, so we have the short video here to help you through a couple of the problems. The first example that I want to look at is this example that is going to remind you of the order of operations. You have several different operations here. Notice you've got brackets right here. Remember, brackets work like parentheses. I've got a set of parentheses here because this is a negative number. And then I also have these straight lines, which those are absolute value. By definition, absolute value means that you perform the operations on the inside, but after you take the absolute value, you always take the positive, it's going to be the positive value of whatever is in between here. So in a certain way, these absolute value actually works kind of like parentheses in your order of operations. So we're going way back to several sections back where we talked about the order of operations. So remember that the first thing in the order of operations is that you do whatever is in parentheses. So I'm going to consider this set of parentheses here in the brackets, and I'm going to do this operation first, but I'm also going to do this operation inside of the absolute value. So whenever I do that, I end up getting a negative 15 divided by a negative 5 means it's going to be a positive 3. And then I'm going to have absolute value of negative 4 minus 11, which is negative 15. All right, but that's the absolute value. So what I'm going to do now is I am going to, oh, and this minus right here is just this minus that just came down, okay? So we didn't want to lose that. Now we're going to take the absolute value. And so what the absolute value did is it says take the positive value of whatever is in here, and that would be 15. Okay, now this minus came straight down. I dropped the brackets here because they were not necessary. So the next thing I want to do is I want to look at this order of operations. I've done all my parentheses, so there are no exponents. The next thing is multiplication and division. And so actually I'm going to have this negative 6 divided by 3, and that would be the next operation that I'm going to do. So it turns out negative 6 divided by 3 would give me this negative 2. And so now I've got just 3 separate, and they're all subtraction. So I've gotten rid of all my multiplication and division, and now I'm down to addition and subtraction. So I'm going to combine these numbers. I'm going to take the negative 16 minus 2, which is negative 18, and then negative 18 minus 15, which is negative 33. And that is actually going to be my final answer. So that's just a quick reminder of order of operations and how absolute value works. The next example that I want to look at is the number negative 1. And you're going to have some problems like this in your homework where you have to take negative 1 and raise it to exponents. So the first thing I want to do is I want to say negative 1 to the second power, which we also say negative 1 squared. That is going to be the same thing as negative 1 times negative 1, which turns out to be a positive 1. Okay, now I want to take a look at negative 1 to the third power. Well, this is going to be negative 1 times negative 1 times negative 1. And when you do that, you get a negative 1. Okay, so it turns out that if you raise negative 1 to any even power, 2, 4, 6, 8, 100, 1 million, 1 million and 2, it doesn't matter as long as it's even, the answer will always be 1. If you raise it to an odd number, 3, 5, 7, 103, it doesn't matter what that number is, if it is odd, you will get an answer of negative 1. So an even number can be written as 2k, which is, k is a natural number. So any number, any natural number 2k will represent an even number. Okay, an odd number can be written as 2k plus 1 or 2k minus 1. All right, you're going to need that for your homework. So hopefully that will help you get through that problem. The last example that I want to look at says find a finite subset of z, which is the integers, that is closed for multiplication. Okay, so what we need to do, a finite subset means that it is a definite number, okay? So you're not going to have an infinite number, it is a definite number. So z, the integers, that is going to be any of the numbers, the negative numbers, but we're looking at negative natural numbers, and then 0, and then all of the natural numbers. So you put all of those together, and that gives you the integers. Now, I want to look at an example of the subset 1, 2. So this is a finite subset of integers. Now, closed for multiplication means I can take any elements out of this subset, I can multiply them together, and the answer is going to be in this subset. Okay, so I can say 1 times 2, the answer is 2. And since 2 is in this subset, that works. That's great. Except that we also have to look at any member multiplied by itself. So 1 times 1. That's 1. It's a member of the subset, so that works. But 2 times 2 is 4. Now, 4 is not an element of this subset, so it turns out that this is not closed under multiplication. This example is not closed. Now, your task is to find a subset that is closed. I'm going to give you a few hints. One is it's going to be a small subset, okay? 2 is that subset could be just one number, and that would work. And so think about that. I would think about very small numbers, and I think if you just think about it for a few minutes, now that you've seen this example, you should be able to come up with a subset. There's a few different subsets that will work. They all contain similar numbers. So anyway, I want you to think about that, and hopefully this will help you get to your answer. All right, good luck with your homework.